it? It doesn't say. It says solve the equation. So what type of equation is it? Because if I am able to correctly identify the type, I'm thinking that I should be able to solve it correctly. What type of equation is it? Radical. Then I look at the index of the radical, which is 2. So what should I do? What is the only option here? Which is not a 100% legitimate operation. It's not a basic operation, but I have to use it. And at the end, what do? Go back and check, right? Okay, yes, I will square both sides. Perfect. So when I square the left-hand side, what do I get? And the right-hand side, I have to be careful because I have an agreement, right? I cannot breach that contract. What is it? Perfect. Very good. What type of equation is this? So the initial equation was radical. What type of equation is this now? Quadratic. Very good. The reason why I insist that we identify them correctly is because the terminology is also important. I won't be able to speak a foreign language if I don't know words. So the same thing here, right? So what will be the next step? How do I solve a quadratic equation? I have to set it equal to 0. So it doesn't matter which side you want to go to. I would like to keep it on this side because then x squared is positive. But I can look at the equation from this side or from this side. It doesn't matter. So if I look from this side, then I'm adding x and I'm subtracting 13. And I think that you should have this in your notes. I think it's a problem we solved together. Okay, what do I do next? Good. How do I factor it? Yes, which one is negative? 3 and 4 is not good enough. X minus 4 and x plus 3. And then we have two possibilities. But they come with big question marks. So what do I have to do next? Yes, I have to go back. This is not the original problem. This is the original problem. The square root of 13 minus x equals x minus 1. When I go back and plug in 4, it works. The square root of 9 and 3, I'll say yes. But when I plug in negative 3, it does not. The right-hand side is negative 4. The left-hand side is the square root of 16, which is 4. 4 does not equal negative 4. So I will say this is the only option. Any questions on this? Any questions? Okay, very good. So I'd like to go back and finish up chapter 10 with complex numbers because we have not talked about dividing complex numbers and we haven't talked about powers of I. And then we'll start reviewing for the entire chapter 10. So, yes. Yes, we should have this. I think we did this problem. Okay, so give me two complex numbers so we can divide them. We studied last time when we finished. Let me go back. Where is it? Don't tell me I'm logged out. Oh, I'm not. Oh, wonderful. So at the very end, we looked at multiplying. So we did not talk about division of complex numbers and the powers of I. Okay, so give me two complex numbers that you would like to divide.
4i.
Too simple. I need a real part to show the whole thing. But you're right. If you say 4i and 2i, I'll simplify and I'll get 2. But I cannot simplify if you want to keep those let's say 1 minus 4i over 3 plus 2i. In this situation, I cannot simplify anything because they're terms, not factors. Okay, do you remember, assuming that this is a radical expression, forget about I. Imagine that you have radicals in here. What would you have done to rationalize the denominator? If let's say we had 3 plus 2, the square root of 5. What would you multiply and divide by? 3 plus 2, the square root of 5. What would you have here? That's it. That's the procedure. This is 10.7, complex numbers. It's exactly the same procedure. And you may ask why, and I'll show you why in a moment. But you may ask why. How come that when I divide two complex numbers, I multiply and divide by 1? This is 1. I'm not changing anything. So how come that I multiply and divide by the conjugate of the denominator? And here's the reason why. Here's why. 3 plus 2i multiplied by 3 minus 2i will always be a real number. So I want the denominator to be a real number so I can separate, you'll see in a moment, I can separate the real part from the imaginary part. This is the only way. Only if I clear the complex number from the denominator. So division of two complex numbers really requires me to clear the complex number from the denominator. That's the only way. Because when I multiply complex conjugates, the answer is always real. Furthermore, it's positive. Okay, so when I multiply a plus bi, what will be the complex conjugate of a plus bi? A minus bi. This is always going to be a real number. So in order to divide two complex numbers, I multiply and divide by the complex conjugate of the denominator. In other words, I make the denominator, like before with no radicals, I make the denominator real. That's the only chance we have. So now the denominator, a plus b times a minus b, what do I get? A squared 9 minus, it's a difference of squares, b squared. How much is b squared? 4i squared. Very important. 2i squared is 4i squared. Okay, now the numerator has to be distributed. I have no choice. 1 times 3, 1 times negative 2i, negative 4i times 3, and negative 4i times negative 2i is positive 8. Very good. So I will continue here. So what do I replace I squared by? Negative 1. Yes. Very unusual. We know that a number squared cannot be negative, but this is not a real number. Right? Okay, so then let's finish up with the denominator. How much is negative 4 times negative 1? 4 plus 9. Very good. And now the numerator, 8 times negative 1. How much is 8 times negative 1? Negative 8 plus 3. Perfect. Negative 5, and now I combine these two. What do I get? Now I have to separate it into negative 5 over 13 and negative 14 over 13 times I. In other words, I show a plus bi, where a and b are real numbers. A is this number, and b is negative 14 over 13, and that's I. So keep this in mind every time I need to divide, or I have to divide two complex numbers. I refer back to rationalizing. So it's very similar. I multiply and divide by the conjugate of the denominator. Why? I need to make the denominator a real number. So I can separate the real part, which is this, from the imaginary part. We'll have more examples in a minute, but I just would like to talk about powers of I. So all I know about I is this. It's the square root of -1, and I know I squared equals -1. So give me a power of I to any number you can think of. I to the 15, very good. Since 15 is not an even number and this is the only thing I know, I will have to split it into 14 and I. That's the only thing I can use. So I have I squared to what power will give us 14? 7 multiplied by I. So first I split 15 into 14 and 1. Then I changed I to the 14th into I squared to the 7th. Now I replace what by what? What do you think? I replace by -1. So -1 7 times, what type of number is that? Very good. So the answer is -I. So on the handout, if you'd like to go back and if you have it, on the last page for a second, complex numbers. A complex number has two parts, real part and imaginary part. And this is the form a plus bi, where a and b are real numbers. I is the square root of -1 is the imaginary unit, where what does I squared equal to? I squared equals -1. Okay, and here there are 4 possible answers for any power you can think of I. And here they are. I, -I, 1, -1. So whatever power you want to give us to work on, even this one, 201, or any power, you will always get one of these answers. If you get 5, something is wrong. So give me, yes. Okay, so give me a power of I, the one in the handout, or any power you can think of. So we can work on this. Any number other than 15. Okay, let's work on, let's say 200. When the power is even, very easy. I have I squared to which power? Very good. I squared will be replaced by, how much is -1 to 100? 1. Good. Anything else? Is there anything else you want to try? I to any power you want. And that's the end of chapter 10, and I like to go backwards now with problems.
Thank you.
Very good. I to the 3rd is I squared times I. And I know that I squared is, so the answer is -I. Any other power that you want to try? Let's say I to 2017. What will you do with this? It's not even. You cannot divide it by 2. So then, I to the, very good, times I. So I squared raised to which power? I can divide 2016 by 2. What do I get?
128.
Very good. Times I. Now I replace I squared by, and very good, thank you. And -1 raised to an even power. 1 times I. So that's the way we work on any power of I. And all possible answers are these. One more time, we got 3 of them. We got negative I, we got 1, and we got I. So I, negative I, 1, or negative 1. So I like to go backwards now, starting from section 10.7, and let's work on different problems. So page 640. Because there's so many more different types. Okay. Are we okay with I to a power? Is that okay? Perfect. So let's look at, I think we should do at least one more dividing complex numbers before we go back. So let's say 74, in which we have 6 plus 5i over 6 minus 5i. We're asked to perform the operations. In this case, there is a division of 2 complex numbers. How do I divide 2 complex numbers? What do I need to do? I need to multiply and divide by complex conjugate of the denominator, which is I recommend the top as a special product we have an agreement on, and the bottom is a special product that we have an agreement on. What will you write in the denominator? That's the easier one. Excellent. Then leave it alone, and we'll come back to it. What will you write for the top? I hope that you will use the special product that we have an agreement on, because they are the same. First term squared plus 2 times the first times the second plus the second term squared. And I'm ready when you are. So it's 36 plus, you already performed everything, but I need everyone to see. Yes, so 2 times the first, 10, very good, 60i, plus, very good. See, we don't have to waste our time foiling. Once we understand that those 2 special products, it will just take a blink. Okay, so now, in the next step, I have to replace what by what?
Squared by -1.
Right, so this is -1 and this is -1. The denominator must be a positive number. So -25 times -1 is 25 plus 36, 61. Good. So then this is 25 times -1 will be -25. So 36 minus 25 is? Very good. Now we're ready to split it. You cannot simplify, you can only write this, which shows that you know how to write a complex number in the form of a plus bi. I want to draw your attention to another important detail. Here is the detail I'm referring to. If I want to multiply the square root of 4 by the square root of 9, am I allowed to write the square root of 36? Is this true going back and forth? Absolutely, this is correct. Now here's a question. What about this? Am I allowed to write this? -4 times -9 is 36, right? Am I allowed to write this? Good. I'm happy that you're not answering because this is false. These two are not the same. And you could say, how come? Well, this property works only for real numbers. It does not work for complex numbers. This is not a real number. It has a negative number under the square root. This is not a real number. It has a negative number under the square root. So I cannot apply this. So what I can do is simplify each of these radicals like we did last time. The square root of -1 multiplied by the square root of 4 times what?
The square root of -1
Excellent.
times the square root of 9.
Right. But what is this that we know? This is I, and this is, you're right. Very good. So what is this? What is this? So I have to multiply 2 by 3, and I get,
6.
and I'm I by I. So what is the answer?
6 I squared.
But how much is I squared?
-1.
Look at the answer. Is that clear why it cannot be the square root of 36? Because this side is -6, and this side is 6. So this only proves that we cannot assume or apply the same rules we know from real numbers to complex numbers. So now I'd like to choose an example from your book. Like, let's say, 22. You can choose, of course, if you like. 22 on page 640. The square root of 3 multiplied by the square root of -27. Can I write that this is the square root of -81? Of course not. Why? This is a real number, but this is an imaginary number. This is not a real number. So I cannot use this property unless both are real numbers. However, what I can do is copy the square root of 3, which I cannot do anything to, and then split this. Can anyone tell us how to split it?
Times the square root of -1.
Very good.
Times the square root of 27.
Right. So let's go ahead with the square root of 27 and say the square root of 9 times the square root of 3. Excellent. You can do that in the second step. That's fine too. So I split 27 in 9 and 3 so I can simplify. So how much is the square root of 9? How much is this product? Exactly. How much is this? Good. So what is the answer? Very good. Problem 39. 4 minus 2i squared. Allow me to remind you, we have an agreement on this. How many terms will you give, at least initially? Then maybe I may be able to simplify or combine like terms, but at least initially, how many terms will you give for sure? 3 terms. And they are 2 times 2 times 4. Plus. Excellent. How much is I squared again? Okay. So how much is 4 times -1? How much is 16 minus 4? And minus 16. So initially I had 3 terms, but because of I squared that has to be replaced by -1, it collapsed into 2. I don't have anything else here unless you want to practice something. If you have your book, if you want to choose. I don't have anything else. You know what, maybe this. Yeah, 37. Let's work on 37. So in 37, I have the square root of 3 plus 2i multiplied by the square root of 3 minus 2i. So here's a question for you. Are these complex conjugates?
Yes.
What will the answer be? A real number. It will be also positive, but it will be a real number, no complex. Good. So let's use the contract. What would you say? However, I squared is, so negative 4 times negative 1, 4 plus 3. I can't think of anything else. Oh, yeah, I just found another example. On page 641, and this is really the last thing, I can't think of anything else. Yes, Becky, go ahead. You wanted to say something? Okay, sorry. Let's say 110 on 641. 4 minus the square root of negative 8 divided by 2. They're asking us to simplify this. Remember, I cannot simplify like this. I have to separate them, but not yet. So 4 is 4, 2 is 2, minus outside there is nothing, but I have to work on this. This isn't simplified yet. Have to fully simplify it, and then I'll see what I can do. So what can I do to the square root of negative 8? 4 minus what? Excellent, times. Right, but I will write it as 4 and 2. Very good. So then I have 4 minus. What does this become? So this becomes 2. What does this become? I. So I have a 2. I have an I, and I have the square root of 2. I have to write it like this. We cannot write anything behind the square root or any root. So you can say, well, wait a minute. You just told us that the complex number has to be written as a plus bi. So why are you putting I between 2 and the square root of 2? Only because b, the imaginary part, has a real number that has a radical. We don't write anything behind a radical. Why? Because by mistake I can do this. And that would be terrible. So that's why we don't write anything behind a radical. It's not a mistake, but we don't write it. Good. So now I can separate it to show the complex number. 4 over 2 minus 2i, the square root of 2 over 2. And yes, each fraction should be simplified. So 4 over 2 is 2, and here I can simplify. So it's minus I, the square root of 2. So this is a plus bi, bless you, where a is 2 and b is negative the square root of 2. In 10.7, we exhausted everything. There's nothing else. Any questions? Okay, so let's go back now to more equations. 10.6, radical equations. I don't see anything else here. I'm looking at the review now at the end of the chapter to copy some radical equations from there. Okay, I found some. So here is 121 on page 646. 2x minus 5, the square root of x equals 3. And then we'll look at more from that page. So let's take a moment and work on this problem. And also we can work on these two problems. So I don't think we did these two from the handout. Can anyone just get us started? First step for everyone to see what we need to do. Can anyone give us an idea of how would we even start this problem? Yes, well, I have to. So I prefer doing this, but it doesn't matter. 2x minus 3 equals 5, the square root of x. It doesn't matter. But you have to be very careful with the negative signs. That is the first step. You can still have negative 5, the square root of x equals 3 minus 2x. You're going to get the same answer. You don't have to erase or change anything. But I would rather have the radical positive, but it doesn't matter really. So what is the second step? After we isolate the radical on the left or right, it doesn't matter. What will be the next step? Say it again. I have to square both sides. Very good. The right-hand side is easy. Easier, anyway. What is the right-hand side? Very good. Do we all agree with 25x on the right-hand side? How many terms would you write on the left-hand side? Of course. Thank you. So what do I write? Okay. Yes? $12x. I completely agree. Now this equation is no longer radical, but it's right. So we have to, very good. Let me know what you get. I copy x squared. I'm sorry, not x squared, 4x squared. And then minus 37x indeed, and plus 9. Good. Because the leading coefficient is not 1, I'm looking for two numbers whose product is this, with the signs, 36, and whose sum is always this. Does Since the product is positive, signs must be the same, either both positive or both negative. But since their sum is negative, what signs do they have to have? Of course. So give me two numbers whose product is positive 36 and whose sum is negative 37. Good. We are going to replace this using the number that you just gave me, just the middle term. I am going to review everything in that chapter with this handout. Okay? So chapter 6 includes all this. So we are going to review it, not for this test, but for the next one. And I do have here a little summary that I created to guide you through factoring from now on forever. Okay, so we're going to go over all this. This is the entire chapter 6, okay, that I gave you today. Okay, so then I go back and I have 4x squared minus x minus 36 plus 9 equals 0. 4 terms, I always think of grouping. So if you want to look at the quick summary at the very end. Any polynomial with 4 or more terms, my only chance is this, grouping. Okay, so I will group without looking at the sorry. I will look later. So right now I want to factor out the greatest common factor from the first two. What do I factor out? Good. What is left in parentheses? What should I have coming out from the other two? I refuse to look before I write it because I may mess it up. Who knows what I'm going to write? What do I have to have coming out of the other two? If I don't have the same thing, I will not be able to continue. So it has to be 4x minus 1. And now I'm ready to look. I need a sign and I need a factor. Without a sign and a factor, I mess it up. What is the sign? Negative. What is the factor? Indeed. Negative 9 times 4x is negative 36x, and negative 9 times negative 1 is positive 9. What comes out from these two terms for sure? Of course, it must be 4x minus 1. And what is left at the end?
X minus 1.
That's it. So there appears to be two options. I have no idea. Because I use the principle that is not 100% legitimate. So I have to go back to the original problem and check. But what are the options? And the other one is 9. Very good. So now 3 pages ago, I'm kidding, not that far, I have the original equation. I have to copy it. So I have 2x minus 5, the square root of x equals 3. And that is the original one. And now I'm going to plug in 1/4. So 2 times 1/4, this is 1/2. The square root of 1/4 is 1/2 with minus 5. Minus 5 divided by 2. 1 minus 5 is negative 4 divided by 2, which is negative 2. Does this equal 3? No. Out. It can just a byproduct of what we just used, the principle of powers. And now I'm replacing x by 9. 2 times 9 is 18. So the square root of 9 is 3. 18 minus 15, is that 3? So I will say yes. Questions? Okay, I think we need more practice on this, right? Very good. Any questions on the previous problem before we choose other problems? I normally say to my students in O12 from the very beginning, there are two topics that are, I don't want to say difficult, but involving, if you want, or dense in this course. This is one of them. The second one will come up in chapter 7. I do have difficulties with my pre-calculus class with this problem. I do have difficulties with my calculus class with this problem. It's not a trivial problem. So, yes?
So for this test, will there be factoring with the leading coefficient that's not 1?
It's a very good question. Well, I would like you to review it. We are going to look at that entire chapter again. No, not before this test. Not before this test. This is part of chapter 11. So chapter 6 and chapter 11 go together. This was considered a prerequisite. But we can practice more of these problems if that's what you want to do. It's a good point you're making. Okay, so let's look at other problems, and then we can come back to this. I have no problem with that. All these problems are on page, they're right here at the bottom of page 3. These are the problems that you're looking at, that you're asking about, all these. Completely factor a trinomial of type a leading coefficient, not 1. See, this one has 1, which is much easier. And this one has any leading coefficient, not 1. If it's 1, it's in this category. If it's not 1, it's in this category. So we can go over this. It's a very good point. Okay, so let me choose more radical equations, and then we'll continue. Where was I? Okay, I see, yes. 122 now, on page 646. As I mentioned before, this is considered known. But I know that not everyone in O11 had the chance of spending enough time on chapter 6. Because chapter 6 is the last chapter in O11, and not everyone gets to that particular chapter in timely fashion. And I spend a lot of time on chapter 6 when I teach O11, because this is the core of the course. Okay, I'm talking too much. So what do we do with this? Let's work on it for a minute. It's far from being trivial, as I said, especially with 2 radicals in it. It's not easy. So let's work on it for a minute, and then we'll work on it together. Can anyone just get us started? Just the very first thought or idea or what you wrote. Exactly. Not term by term. I'm not saying that you would have done that, but I'm just re-emphasizing, not term by term. So if you write something like this, for whatever reason, because it's tempting, it cannot be more than 0 points. I can't give anything for this. So please do not do it. Good. Can anyone give us the left-hand side?
X plus 9.
Excellent. Now you have to be very careful with the right-hand side. Always remember, we have an agreement. We cannot breach that. And when you're ready, please tell me the right-hand side.
4 plus 4 squared x minus 7 plus x minus 7.
Excellent. Excellent. I will see you at the end of this semester if this is the first time I came up with that idea with an agreement, blah, blah, blah. I'm trying to trigger your memory. This is not something that you would think in terms of, day-to-day basis or the real life situation, although it's applicable in so many different ways. We don't really think in these terms. So we'll see at the end of the semester who remembers this and is comfortable with these 3 special products. They are on the handout. So they are in chapter 6. And here they are. This is one at the top of page 3. This is one. This is the other. And here they are, the other ones. We have not talked about these 2. So here's the 3rd one. That's why I wanted to establish that from the beginning, so this is not going to take 4 hours when we work on it. So, good, that is a perfect step. All steps so far are perfect. Now, what is the target in the next step? Right. So I have 4 the square root of x minus 7. This goes away with this because I subtract x from both sides. And this is 4 minus 7, which is, and I have to add 3 to both sides. What do I have on the left? Very good. Remember the 2 key words. Very easy to forget. But the 2 key words will require us to do what now? Simplify. So I will divide both sides by, yes. So what do we get when we divide both sides by 4? Equals? Right. Finally, I'm down to 1 radical. Notice that we had to square twice. We squared once and we got rid of 1 radical, not of both. And now to get rid of the second remaining radical, we have to square again. So I square the left, I square the right, and I get equals. So this is linear now. So I had a radical equation with 2 radicals. Then I had a radical equation with 1 radical. And now it changed into a linear. So then x equals. But it comes with a huge question mark because I used the principle that has a byproduct that I need to avoid. So let's see if this is a byproduct or is it true. So I have to go back to the original problem, which is this. And I have to replace x by 16 and see if it works. The left-hand side is 25. The square root of 25 is 5. This is 16 minus 7, which is 9. The square root of 9 is 3. 3 plus 2 is 5, and the left-hand side is 5 as well. So I will say yes. Okay? Should I look for more radical equations? One more. Very good. So let's take a look. He didn't mean that, Becky. Okay. 159. The square root of 2x minus 1 plus 2 equals x. This is not as hard as the previous one. Can anyone explain why this is not as hard as the previous one? Because it has only one radical, exactly. So let's work on this.